So I go to another video content about expected values and variance, example of that. Okay, so this will be the last video for this week. Okay, right. So expected value and variance. So I will do example 4.6, page 81. Okay, example 4.6, page 81. So the question asks you to, the question is, the growth of clouds seeded with the silver iodide has a density function of gy, okay, and then negative, half 1/2, 2 minus y for between or from 0 to 2. Okay, dia tak guna F macam biasa, dia guna G. Okay, it doesn't matter, any alphabet also can. Okay, but as long as you know that this is PDF or this is CDF, so you can see that the word of from the example it said that is a density function. So this is a PDF, okay, probability density function or probability distribution function. Okay, so this is a PDF. Okay, and then 0 is otherwise. Okay, alright. So then the question asks you to determine the mean. Okay, we want to determine. Okay, mean. Okay, want to determine the mean and also variance. So we find the mean first. So, what's the formula? What's the equation? Okay, you just write first the equation. Mu is equal to expected value. And since this is a continuous class, so you need to use the correct, what we call the correct equation or correct formula. So this one is you will get, or you will use the interval given here, which is 0 until 2. And inside here, class, they have an x. Okay, they have an x, and then you multiply with your fx ds. So what is your fx? So this is your fx. Okay, so kalau you can see here, if you can see here, to make it, if you want to follow the question lah, so because this question use y as a variable, so we just change, okay, y. Okay, so then this is y, and then this is your gy, right? Okay, this is your gy. So substitute here. Okay, y is y. So what is your fy? Your fy here is this one, 1/2, 2 minus y, and then you integrate with respect to y. So simplify lah dalam ni. Inside the bracket you simplify first. So they have 1/2. Okay, sorry, 2 cancel. So they have y minus y square over 2. Okay, careful class. So make sure you cancel carefully. You cannot simply cancel these two and these two. Actually, okay, saya buat balik lah. Okay, to make it clear, okay, we expand this one first. So you will have 2/2 minus y/2. Okay, then this one is equal to 1. Okay, so 1 times y, so you have y. And y/2 times y, so we have y square over 2. Okay, alright, then integrate lah. Okay, now we will integrate. Okay, so then substitute the value 0, 2. So you get 4/2 minus 8/6. Okay, the first one, then minus 0, 0 lah. Okay, 4/2 is 2, 8/6 is 2/4. Okay, for this, so you can use your calculator. So you will get your mean is equal to 2.3. Okay, your mean is equal to 2.3. Okay, next we want to calculate the variance. Okay, variance. So the variance is equal to EY square minus EY square. Okay, careful kat sini, they have two different term. This one is y square, this one is EY square. Okay, so how to find this one? Okay, we use the same equation. Okay, but now in front of your function, now we have a y square. Okay, your function tadi sama lah, the same function, 1/2, 2 minus 1, 1/2, 2 minus y. Okay, but now here instead of y, okay, just now we just write y times this one, right? Y times fx. So now it will be y square. Okay, y square. So this is for this one. How about this one? Okay, so minus EY squared. So we just leave it first. Okay, kita buat ni dulu. Okay, sama juga, you expand this one, so y square, this one is become 2/2. Okay, saya tulis satu lah, so you can see again here. And then this one is 1, okay, so 0, 2, so this one is y square, this one is y cube. Okay, y cube, and then dy. Okay, and then this one, okay, actually this one, you already calculate it. Okay, mu is equal to EY, and your EY is equal to 2/3. Okay, I repeat, your mu is EY and EY is equal to 2/3. So you just use that answer. Substitute here, 2/3 power 2. Okay, so therefore you need to careful lah. If your mean you calculate wrongly, therefore your variance also will be wrong. Okay, sebab dia akan effect kat sini. Kan, you guna jawapan yang you dapat daripada mean tadi. Okay, kalau mean you salah, so therefore your variance also will be wrong. Okay, right, so solve this one. So it will be y cube over 3 minus y4/8. And then substitute 0, 2 into this one, and so this one will be 4/9. Okay, so substitute, saya tak tunjuk dah lah, so you can substitute by yourself. So it will be 2/3 and then minus 4/9. Therefore it will be 2/9. So the variance is 2/9. Okay. Let's say I add on another one more example. Find out what's the symbol of this? This one is a standard deviation. Okay, standard deviation. How to get standard deviation? You just square root your variance. So your variance is this one. So yeah, so you can leave like this lah. So this is the extra, so you just add on. So this is a standard deviation. So to get standard deviation, you need to count or you need to calculate your variance first. Then baru you boleh dapat your standard deviation. Okay, class. So I think okay, I give you one more example lah. Okay, sebab saya tengok example 4.7 ni quite different. Okay, example 4.7, page 82. So the question here is, let X be the time in hour a lecturer spent for industrial attachment per week outside a university which has a distribution function. Okay, this is a distribution function or PDF. 6x 1 minus x, okay, is from 0 to 1, and another one is 0, so this one is as well lah, other than what. So find the expected value. Okay, the question asks you to find the expected value of gx, of gx 2x plus 8. Class, so it's quite different between the previous example. Okay, so you may see carefully. So the mu or the expected value, usually we use or we write like this, right? Okay, kita tulis EX. So but now for our question now, we will write like this. Kita akan tulis macam ni. So it's no longer x inside here. It will be gx, and your gx is equal to 2x plus 8. Okay. So how to answer it? Okay, it's still similar. Okay, the step will be the same, which is you need to integrate from 0 until 1. But now, suppose before this is x times fx, z x times fx. But now your inside here, okay, this one kalau yang ni lah. Okay, if expected value of x, so this is how we will calculate it, x times fx. But now inside here is 2x, so you will replace it, so it become 2x plus 8, and then just multiply lah with your function just now. So the difference is on this part. Okay, so you need to expand this one first, so carefully. Okay, slowly, tak perlu nak rushing. So to avoid you do the careless mistake. Okay, sometimes saya pun kadang-kadang buat careless mistake juga. Okay, so then okay, dah expand kan, 6x minus 6x. So now we expand it for these two pula. So it will be 12x square plus 48 minus 12x cube minus 48x square dx. Okay, so yang boleh simplify, so kita ada 12x cube, negative 12x cube. So you just rearrange according the power, x cube, and then this one minus minus, so it will be minus 36x square, and then it will be plus 48x. Okay, so integrate. So we have negative 12x 4 over 4 minus 36x cube over 3 plus 48x square over 2, and then substitute 0, 1. So either one lah. If you want to simplify first also okay. Kan, you nak simplify dulu pun boleh, ataupun you nak substitute terus pun tak apa. As long as the final answer you need to simplify lah. So the final answer that you should get is 9. Okay, okay class. So this example is quite different lah. Okay, because it give you the another function which is your gx. Okay, it's not only, I mean, yeah, the question you need to careful lah kalau disuruh ataupun expected value of x, so then we use the original or the standard one lah. But if the question say that find the expected value of something something, for example like this, for of gx to x plus 8, so means that this one you need to replace according to the question given in the equation given in the question. Okay. Okay class, so I think that's all for this week. So we have another, I owe you another video which is example of normal and also standard normal distribution, but that one will be covered in the next week punya syllabus or content. Okay, so for this week we just cover the CDF, PDF, and also the expected value. Alright, okay, so thank you.